This is lesson 1.3, rational numbers in fraction form. So positive and negative fractions are considered rational numbers, and we're going to learn how to add, subtract, multiply, and divide them. Something to note is when you have negative fractions, you have to make sure that you write it with the proper negative sign. So if you have like -1/2, make sure you only write one negative sign. That negative can either be on the top of the fraction, like right here, or it can be on the bottom of the fraction, like this, or it can just be outside of the fraction entirely, like on the left side. All of those are fine. You just have to make sure that if you have a negative on both the top and the bottom, like this example here, then that's considered a positive fraction because those double negatives cancel out. The reason this is true is because fractions are division. If you have 1/2, that's the same as 1 divided by 2. And we already know based on our sign rules, if you're dividing and you have two negatives, they become a positive. Double negatives become a positive. So these are the steps for adding or subtracting rational fractions. You're always going to first change to improper fractions if you have any mixed fractions. Then you're going to find a common denominator, and then you're going to add or subtract the numerators like usual. So you make sure that you only add or subtract the numerators, and you just keep the denominator as that common denominator that you found. It might be helpful to use a number line if you're adding or subtracting the numerators. And then you always end by reducing your fraction to lowest terms. We have two examples here. These are already on improper fractions, so we don't have to convert them. But we do need to find a common denominator. We know that 5 goes into 25, and if we just multiply the bottom and the top by 5, then we'll have a common denominator of 25. So this fraction becomes 10/25. This one stays the same. And then we add or subtract the numerators like normal. We've got 10 minus 3, that gives us 7/25. We don't need to simplify any further because these two numbers do not have any common factors. It cannot be reduced. Second example, we have to first convert this mixed fraction into an improper fraction. So we've got a negative on the outside, and then when we convert this, we've got 2 times 3 gives us 6, plus 2 gives us 8. So 8/3, and this stays as it is. We find our common denominator. If our denominators are 3 and 4, then a common one would be 12. And we can get there by multiplying the first fraction by 4 on the top and bottom, and the second one by 3 on the top and bottom. So 8 times 4, that gives us -32/12. This gives us -15/12. If you need to use a number line for this, you totally can. But if we're at -32 on our number line, and we're subtracting 15, and we're going to go left, we're going to have a more negative number. So -32 minus 10, that would get us -42. Minus another 5 would get us -47/12. And then we see, can we reduce this any further? Well, does 47 and 12 have any common factors? No, they don't, so then our answer is finished. This is another type of problem you might see in the workbook. Write an addition statement using two negative fractions so that the sum is -3/4. So how I would set this up is we know we have two negative fractions that are being added because it's an addition statement. So I kind of set up these boxes for each fraction, and then I fill in the numbers later. So we've got a negative fraction here with a blank numerator and denominator, and it's being added to another negative fraction because we know it's an addition statement. And these add to -3/4. And then we can go backwards and figure out, well, what should we sub into those boxes to make this be true? Well, it makes sense to have the denominator be 4 because this would give you a common denominator to match up with this answer here. Then we just need to figure out what numerators go into this box so that we get -3. So essentially, minus something plus minus something gives you -3. So there's lots of different answers you could do here. One that works for sure is 2 and 1. Because if you've got -2 plus -1, that gives you -3. So that adds up. Okay, moving on. We've got multiplying rational fractions. So here are the steps. First, just like before, you're going to change to improper fractions if needed. And then you're going to multiply the numerators together, and you'll multiply the denominators together. You don't need a common denominator when multiplying or dividing fractions. We've seen these sign rules before, so make sure we follow them. If we have two positive numbers, it gives us a positive. If we have one of each, that's going to give us a negative. And if we've got two negatives, that gives us positive overall, because that's a double negative leading to positive. Then you always end your questions by reducing the fraction to lowest terms. So let's try some examples. These are in mixed fractions, so we have to convert them first. We've got negative, so we've got 2 times 7 is 14 plus 2, so 16 over 7. And our second fraction, we've got negative, so then it's 3 times 4 is 12, plus 1, 13 over 4. And then we can go right ahead and do this multiplication. It doesn't matter if they have common denominators or not. So 16 times 13, you can do this on the side if you don't know it off the top of your head. I would not, but I just did it on my calculator quickly to save us time. So we've got 208 on the top. We know it's going to be positive because we have a double negative. On the bottom, 7 times 4, that gives us 28. Then we have to ask ourselves if this can be reduced any further. So what numbers might go into both 28 and 208? Well, we know that 2 would go into both of those. We know that 4 goes into here. So if we try it out, is 208 divisible by 4? So if you also did this on the side here, you would find out that yes, it is divisible by 4, and it gives you 52. And our bottom would become 7, 28 divided by 4. So this is now fully reduced. 7 and 52 don't have any common factors. And that is done. Next one is actually a little simpler. We don't have to do any conversions. It's already improper. So we just multiply the tops, negative 25, and multiply the bottoms, 28. It cannot be reduced any further. And the sign we know is correct. We've got one of each, so it'll be negative overall. And that one's done. Lastly, dividing rational fractions, very similar to the steps we just went over. Change it to improper fractions first. When we're dividing fractions, you keep the first fraction the same, like this example. You change the sign to multiplications. You turn it into a multiplication problem. And then you flip the second fraction. So 3 over 5 becomes 5 over 3. And then you just have a normal multiplication question. You multiply like normal, you check your sign, and you fully reduce. So our last problem here, let's convert this to improper. We've got negative, 2 times 1 gives us 2, plus 1. So we've got 3 over 2. Divided by negative, 2 times 4 is 8, plus 3 is 11 over 4. Put this in brackets as well. We keep the first fraction the same, change the sign to multiplication, and then flip our second fraction. Now we multiply like normal. Negative 3 times negative 4 gives us positive 12. 2 times 11 gives us 22. We check if we can reduce any further. Well, these are both divisible by 2. So that would give us 6 over 11. And then that's complete. So that is how you deal with rational numbers in fractional form.